Please title these notes Geometric Applications 9 Notes, Advanced Tangent Lines. By the end of this lesson, you should be able to do tangent line problems involving parameters, reading from graphs or tables, or difficult computations. Let's start off with some of our sneaky problems. First of all, tangent lines with parameters. Remember that a parameter is similar to a variable, except that it is a number. It's not varying at all, but it's represented by a letter. But the thing is that even though we don't know what number that letter stands for, it only stands for one number. So let's just say what a parameter is. And here's an example problem. The line 2k plus y, that's 2x plus y, equals k, where k is a constant. That means k is our parameter in this case. This line is tangent to the graph of y equals x squared. What is the value of k? Now, there are a couple of really key things to notice about this. First of all, we know that if we have this tangent line, that means the slope of the line equals the derivative of y equals x squared at some point. We don't know what that point is. I'm just going to put little question marks. But that's what we're trying to figure out. So let's start off just by figuring out what the slope of the tangent line is. Two x plus y equals k. To get slope-intercept form, we simply get y by itself, so negative 2x plus k. So that means that the slope of the tangent line is negative 2. Now, somewhere, for some value of x, we know that y equals x squared is also going to have a slope of negative 2. So let's figure that out. Remember, we're talking about the derivative. So if we start with the function y equals x squared, we take the derivative of that, that's 2x, and we know that at some point we want that slope, that y prime, to equal negative 2. Divide both sides by 2, x equals negative 1. So when x equals negative 1, we know that the slope of the tangent line is going to be negative 2, and the slope of the function itself is also going to be negative 2. So we're getting really close. Now we know x. We're trying to find k. So if we also can find out what y is, and we plug both those in, then we can solve for k. So what I'm going to do is I'm going to use this original function and this, substitute in, y equals negative 1 squared, y equals 1. So that means that the tangent line (2x plus y equals k) goes through the point negative 1, comma 1. So that means that we can use this, substituting for x and y, solve for k. And there we go. K equals negative 1. Let's do a check for understanding problem on that one. Let's say the line negative 3x plus y equals k, again where k is a constant, is tangent to the graph of y equals x squared minus 5x. What is the value of k? Go ahead and solve that one on your own. Restart the video when you're ready. Pause the video now. Okay, so once again we know this is a tangent line, so that means that the slope of this tangent line equals the derivative of this at some point. So here we found the slope of the tangent line. Now we'll work with the function. The derivative is 2x minus 5. So at some point, that derivative also equals 3. Add 5 to both sides. Divide both sides by 2. And now we've got our x. If we can find y, then we can find k. So y is 16 minus 20, y equals negative 4. Now we can take both of those and put them into our original equation. So this is negative 12 minus 4 equals k. K is negative 16. You should also be able to find tangent lines when you have to read either from a graph or a table, so that's our next section. F prime, the derivative of the function f, is graphed below. This is f prime. If f of 1 equals 2, write the equation of the line tangent to f of x at x equals 1. So the first thing is that we know we have our usual equation for tangent line. So we need to know a point, an xy point, and we need to know the slope. So the key thing here is that this is a graph of f prime. It's not telling us anything about y and x of f. But we are told, because f of 1 equals 2, that means we have the point (1, 2). So that's our x and our y. Now we just need to find our slope. We know that the slope, we're going to be at x equals 1. So that's f prime of 1. This is where the graph comes in handy. We just have to know what we're looking at. F prime of 1 is this point right here. That I labeled it because that's the only important one. It equals -1. So that means that all of this just goes right in here. Y minus 2 equals -1, x minus 1. There we go. Sometimes we have a graph or a table for f, and we then have to go and figure out something about f prime. So the table below gives values of x and f of x. Estimate f prime of 4. So first let's turn this into a sketch of a graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'll do just a little rough sketch. There's 1, 0, 2, 3, 4, 5, 6, 9, 8, 12, 10, 15. Right about like that. Now we have no idea what this actually looks like. It could be some, completely, radical, weirdo, sort of funky curve like that. Well, actually that wouldn't be a function, but almost like that. Or it could go in some completely other different direction. We really don't know. But our best estimate of the slope of the tangent line at x equals 4 itself is going to be the slope of the secant line between the two nearest points. Basically what we're looking at is we don't know exactly how this curve is going. But it's probably, our best guess, going to be having a positive slope because the function overall seems to be increasing, and maybe it's the case that it actually goes up here and then sharply down here and then back up like that. Maybe it does, maybe it doesn't. There's no way for us to tell. So our best estimate is the slope of the secant line Remember, secant line is just a line between 2 points instead of tangent to 1. So our tangent line right there, our best estimate, this line right here, going from the point 2, 3, the point 6, 9. So that's change in y, 9 minus 3, over change in x, 6 minus 2, (1.5), right, like that. Some sort of estimating the slope of a tangent line from a table shows up really frequently in applications for real-world problems. So you should be familiar just with the idea that if you're trying to estimate the derivative of a function and all you have is a table, you're going to be looking at the slope between the two lines on either side of, between the 2 points on either side of a point that you're interested in. The remainder of this lecture is just you're looking at computationally difficult tangent lines. So for each of these, once I write it, pause the video, try to do it on your own, see if you can, and come back to the video each time when you think you've got it. So these are computationally if f of x equals 3 ln x over 4 and f prime of x equals 3 over 4x, find the equation of the line tangent to f of x at x equals 1. Okay, for our tangent line, we know we're going to have y minus y1 equals mx minus x1. So we need first a point. F of 1 equals 3 natural log of 1 over 4. The key thing here is to note natural log of 1 equals 0. That's just got to be memorized. So that's 3 times 0 over 4, or 0. So that means we have a point. X is 1, y is 0. Actually, I guess this is x1, this is y1. And then for m, we need to find f prime of 1. We have this equation right here, 3 over 4 times 1, 3/4. Plop that in here, y minus 0 equals 3/4 x minus 1. If g of x equals x times f of x, what is the slope of the line tangent to g of x at x equals 0 if f of x equals sine x over e to the x? We're just asking for the slope of the tangent line, so this really means find the derivative g prime of 0. That's all this really was asking for. So g of x, this is really, the really tricky thing about this is just make sure you read the problem. This is x times sine of x over e to the x. So we have both the product rule and the quotient rule going on. We could really, I think, do them in either order, but the way that I've written it out, the quotient rule is sort of the outside one. So let's go ahead and work with that first. So g prime of x, the quotient rule we know is the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Now we need to work these out. Now this, notice we have a product rule right here. So inside this whole thing we're going to have the derivative of the first times the second plus the first times the derivative of the second. That whole thing is just this little piece right here. So then we've got e to the x still next to that, minus x sine x, and the derivative of e to the x is just e to the x. Exponents multiply, that's e to the 2x. Derivative of x is 1. Derivative of sine x is cosine x. All e to the x minus x sine x e to the x. And now we're looking for g prime of 0, so we can do that. Sine of 0 is 0. Cosine of 0 is 1. E to the 0 is 1. 0 times 1. All over 1. And so then what we have here is, oops, my bad, x is 0. This should be a 0 right here. So this is going to give us 0 plus 0 is 0 times 1. This all subtracts to be 0 over 1. 0 times 1 is 0. 0 minus 0 is 0. There's 0 for our final answer. This next problem, what is the slope of the tangent line to y squared minus 2x squared equals 6 minus y at the point 0, 2. Again, slope of the tangent line is just saying derivative at 0, 2. Now notice that we can't get y by itself because we got this y squared here. This is going to be using implicit differentiation. So if you don't know how to do implicit differentiation, go back and look at the lecture that's titled Implicit Differentiation. Go back and review that first. Really what's going on here is just that we go to take the derivative of this, and we're going to take the derivative of every single piece. So the derivative with respect to x of y squared minus the derivative of 2x squared, derivative with respect to x of 6, minus the derivative with respect to x of y. Remember, if these variables don't match, that means that we have to do a funky type of chain rule. So we do 2y, and then we're doing the derivative of the inside function with respect to x. We don't know what y is, so we just notate it like that. These variables match, so it's just the standard. Bring down the exponent. 2 times 2 is 4x. Derivative of a constant is 0. And then this, again, that's that funky little chain rule thing because the variables don't match. Just like that. Okay, now we can treat this dy dx that we're trying to find, because that's our derivative, just like another variable. So I'm going to add dy dx to both sides. Add 4x to both sides to get it over here. Can factor out. Now I can divide both sides by this 2y plus 1. Now I've got that equation. Now I know what x and y are, so I can just plug those in. Four times 0 is 0, 2 times 2 plus 1 is 5, 0. Complete coincidence there happen to be a bunch of problems coming up to 0 this round. Okay, our final one involves the derivative of inverses. Specifically, inverse tangent of x. Go back to the lecture on derivatives of inverses if you don't know how to take this particular one. It's just a formula, just kind of gets to be memorized. Again, slope of the tangent line at x equals 3 means find f prime of 3. So let's start out with f prime of x. Just got to memorize this one. The derivative of arctangent of x is 1 over 1 plus x squared. Just is. F prime of 3, 1 over 1 plus 3 squared. 1/10. That concludes these notes.